Hello and welcome once again to the Aakash BYJU'S JEE channel. My name is Atiullah and we are live with the 45-day crash course which is absolutely free on YouTube. Alright, so in this crash course we are doing a lot of things. We are doing one shot series, okay, in which we are completing one chapter in one shot. We also have a deluge of videos which we are creating for your concepts and for your revision, and one of those genre of videos is this, which is the rapid revision. Okay, and in this rapid revision we are going to do work, power and energy. All right, so people have started joining in. Ankit Kumar, namaste, कैसे हैं आप? यूनिक बुद्धा, नमस्ते, हाउ आर यू, क्या हाल चाल है? आर यू गाइज ऑल रेडी फॉर दिस ऑल इम्पॉर्टेंट सेशन? ठीक है. पवन राज इज आस्किंग सर दिस इज डिटेल्ड और नॉट. पवन, ये डिटेल्ड है, ठीक है, बट इसका नाम क्या है? रैपिड रिवीजन. रैपिड रिवीजन का मतलब क्या होता है कि ऑब्वियसली हम लोग थोड़े कम टाइम में, ठीक है, काफी कम टाइम में काफी चीजें कवर करेंगे, जिससे, और ये सारी ऐसी चीजें हैं जो हम टॉपिक्स की बात करेंगे, ये ऐसी चीजें हैं जो मोस्ट लोगों को पता होती हैं, आपने पढ़ी है बट आप भूल चुके हो. तो आपके रिवीजन को बूस्ट करने के लिए हम लोग रैपिडली ये रिवीजन करेंगे. ऑलराइट, तो इसमें हम क्वेश्चंस भी करेंगे, इसमें हम थ्योरी भी करेंगे, एंड हम कोशिश करेंगे कि आपके जो रिवीजन का प्रोसेस है उसको एक्सपेडाइट किया जा सके. योर रिवीजन बिकम्स मोर एफिशिएंट, मोर इफेक्टिव एंड क्विक एज वेल. इसीलिए इसका नाम है रैपिड रिवीजन. ऑलराइट, सो नेहा कुमारी इज हियर. हेलो नेहा. ओपी प्लेयर मिश्रा इज हियर. हेलो विमल, नमस्ते. पवन सर, जेई के क्वेश्चंस होंगे. जेई के कुछ क्वेश्चंस जेई के होंगे, कुछ क्वेश्चंस अलग से भी होंगे. शेट्टी श्रेया इज ऑल्सो हियर. हेलो. Ankit is saying sir already done this chapter but not enough question practice, what should I do? ठीक है, तो अंकित क्या करेंगे हम लोग जल्दी से थ्योरी रिवाइज करके कुछ अच्छे क्वेश्चंस करेंगे, और आज के रिवीजन के बाद आप जाके प्रीवियस ईयर क्वेश्चंस या अपने बुक से क्वेश्चंस आप सॉल्व कर सकते हो. 10-20 क्वेश्चन इसके ऊपर सॉल्व कर लोगे तो आपका टेंशन खत्म हो जाएगा. ठीक है. Alright, chalo. Alright, let's not waste any time because this session is going to be super rapid. It is going to be super effective. It is going to be super quick. So I want your undivided attention for the next 50 minutes. Alright, so if you're ready, quickly give me a thumbs up and we are all set to go. Chalo, fatafat give me a thumbs up and be ready with your notebook and pen. You can make short notes. You can also solve questions along with me, and you can join my Telegram channel. The link will be in the description, so you can join my Telegram channel. You're going to get the PDF notes over there. You're going to get questions, solutions over there. Okay, so join that channel and that is going to help you with your preparation, and उसमें भी मैं कुछ कंटेंट डालता रहता हूँ. चलो, all set. This is a power packed session. If you are ready, let's go. Alright, सबसे पहले वेटेज. What is the weightage of this chapter? जेई मेन में 1 से 2 क्वेश्चन आते हैं. जेई एडवांस्ड में, सॉरी, जेई मेन में 1 से 2 क्वेश्चन आते हैं और जेई एडवांस में लगभग ऑन एवरेज 1 क्वेश्चन आते हैं. ठीक है. क्या इसका मतलब है कि इसका वेटेज बहुत कम है? क्या इसका मतलब है कि ये चैप्टर इतना इंपॉर्टेंट नहीं है? बिल्कुल भी नहीं. ये चैप्टर के वेटेज से उतना इंपैक्ट नहीं पड़ता है जो कि इसके यूज से इंपैक्ट पड़ता है. ये चैप्टर वर्क, पावर, एनर्जी, ये जो कंजर्वेशन ऑफ मैकेनिकल एनर्जी, वर्क पावर, वर्क एनर्जी थ्योरम, पावर का कॉन्सेप्ट, वर्क डन का कॉन्सेप्ट, ये सारे कॉन्सेप्ट जो है आने वाले आगे के सारे चैप्टर्स में हेल्प करते हैं. आप कोई भी चैप्टर नहीं पढ़ सकते हो अगर ये चैप्टर आपने नहीं पढ़ा है. सो दिस इज वन ऑफ द मोस्ट इंपॉर्टेंट चैप्टर्स एंड इसको बहुत अच्छे से करना है. इज दैट राइट? प्रज्वल इज आस्किंग सर मेक सीरीज ऑन जेई मेंस मोस्ट इंपॉर्टेंट पीवाईक्यू. वो कर रहे हैं ऑलरेडी प्रज्वल. आप सब्सक्राइब करो चैनल को, आपको नोटिफिकेशन मिलता रहेगा. वो हम ऑलरेडी कर रहे हैं. ठीक है. हमने मैराथन सेशन किया था 5 घंटे का, जिसमें हम लोग 50 पीवाईक्यूज वगैरह किए थे. ठीक है, वो हम करते रहेंगे. कितने आवर का सेशन होगा? 50 मिनट्स. ठीक है, इट्स अ पावर पैक्ड सेशन. इट विल बी ऑफ 50 मिनट्स. लेट्स नॉट वेस्ट एनी टाइम. चलो, तो ये चैप्टर पढ़ना बहुत बहुत जरूरी है. ये चैप्टर आपने नहीं पढ़ा तो आपका कोई होप नहीं है. ये चैप्टर पढ़ना ही पढ़ना है. ऑलराइट, चलो लेट्स स्टार्ट. तो किसे स्टार्ट करें? फटाफट वर्क के डेफिनेशन से स्टार्ट करते हैं. ओके तो सबसे पहले हम बात कर रहे हैं कांस्टेंट फोर्स की। ध्यान रखना, वी आर टॉकिंग अबाउट कांस्टेंट फोर्स व्हिच इज कांस्टेंट बोथ इन मैग्नीट्यूड एंड डायरेक्शन। तो वर्क डन फॉर अ कांस्टेंट फोर्स क्या होता है, वो हो जाता है F डॉट एस, यानी F और S का क्रॉस डॉट प्रोडक्ट, जो कि बन जाता है FS cos थीटा। तो F और S के मैग्नीट्यूड पे तो डिपेंड करेगा ही, बट उसके एंगल पे भी डिपेंड करेगा। ठीक है। Fahim is asking, is this zero to hero series or rapid revision? Fahim, this is rapid revision series. Okay, and we are doing work power energy. All right. तो अब ये जो cos थीटा है, इसकी वजह से क्या होता है? ठीक है, आप दो तरीके से वर्क डन निकाल सकते हैं। पहला तरीका क्या है कि आप F cos थीटा इंटू S लिख सकते हैं। F cos थीटा का मतलब क्या है? F cos थीटा विल बी द कॉम्पोनेंट ऑफ फोर्स इन द डायरेक्शन ऑफ डिस्प्लेसमेंट। उसको आप डिस्प्लेसमेंट से मल्टीप्लाई कर दो तो वर्क डन निकल जाएगा। या फिर आप उल्टा काम भी कर सकते हो, आप F इंटू एस कॉस थीटा भी कर सकते हो। मतलब S का कंपोनेंट आप फोर्स के अलोंग निकाल सकते हो। ठीक है, दैट विल बी S cos थीटा एंड देन मल्टीप्लाइड बाय F इज गोइंग टू गिव यू व्हाट? इट इज गोइंग टू गिव यू द वर्क डन। ओके, जोगेंद्र इज सेइंग, सर मैंने ये आपसे 2023 में पढ़ा है, तो मैं अभी इसके PYQs कर सकता हूं इस सेशन के बाद। यस एब्सोल्युटली, इसके बाद आप PYQs आपको बिल्कुल करना चाहिए। ठीक है। BGM सेइंग, कुड यू एक्सप्लेन दिस इन इंग्लिश? श्योर BGM, आई विल ट्राई टू कीप इट a lot in English. All right, chalo, let's get started. Now, depending on theta, there are some special cases. What are those special cases? If the angle between the force and the displacement is between 0 to 90 degree, then cos of theta is going to be what? It is going to be positive. So the work done is going to be what? The work done is going to be positive. If there is an obtuse angle between force and displacement, then you can obviously see that the work done is going to become negative. And a very special case is when theta is 90 degree, when the force is perpendicular to the displacement, the work done would be 0, because then cos 90 degree will be 0. Is that right? All good? Perfect? Chalo, let's move forward. Next, when we have an object and there are multiple forces acting on it, and we have to find out what is the work done on that object. Okay, so whenever we are talking about work, we need to ask two questions. The first question is work done by which force? Okay, the first question you need to ask is the work done by which force. The second question you need to ask is work done on what? So here we are seeing that there's an object and there are many forces acting on this object. We need to calculate the work done on this object. And how do we calculate the work done on this object? The work done will be the summation of work done due to all the forces. Is that correct? The work done would be the summation of work done by all the forces. Now, if we take S common, then we are going to get F1 plus F2 plus F3 and so on. And then finally what we are going to get is, this is going to be the summation of force or the net force. Okay. So if you have to find out the work done on a particular object where multiple forces are acting, what you can do is you can find the resultant force, and then because of that resultant force you can find the work done, and that is going to give you the correct answer. Is that correct? Okay, any problem so far? If there is any problem, you can stop me and ask your question, ask your doubt. We are live, you can make use of it. So quickly give me a thumbs up if everything is clear so far. Okay, let's go. What is next? We want to find out what is the work done by gravity. Okay, work done by gravity is equal to what? What is the work? What is the gravitational force? It is mg. So it is going to become mg dot s. Okay, so if it is going up by a height of h, okay, if it is going up by a height of h, mg is what? Mg is opposite to the height. Okay, mg is downwards, height is upwards, so the work done is going to become what? It is going to become minus mgh. And if it is descending by a height h, then the weight and height are going to be in the same direction. Weight and displacement are going to be in the same direction, so the work done is going to become what? It is going to become mgh. Is that correct? Okay, even if the displacement is like this, even if the displacement is like this, is it going to make any difference? Can you tell me? Now, even if the displacement is not absolutely vertical, if it is making some angle with the vertical, is that going to make any difference to the work done? Quickly tell me. Think about it and quickly tell me. What do you think? Is there going to be any difference? What do you think? Or is it going to still remain MGH? What do you think? Come on guys, quickly answer. What do you think? Change will be there, right? Somesh is saying change will be there. Somesh, change will not be there. Kyunki this is a dot product. And like I said, this becomes mg into s cos theta. Okay? So what matters is not the displacement, but the component of displacement along the direction of force. What matters is not the displacement, but the component of displacement along the force. So the component of displacement along the force is still going to be h. Is that correct? It is still going to be h, so the work done will not be different. Is that correct? So it only depends on the height, it does not depend on the actual displacement. Is that correct? Yes, Chittaranjan is absolutely correct. Chalo, let's go to the next force. Let's try to figure out what is the work done by a spring force. Okay? So the force exerted by a spring is kx. Is that right? If it has x elongation or x compression, the force is kx. Now this is a variable force. And when you have a variable force, then we cannot use F dot S. Remember this. F dot S can only be used if the force is constant, both in magnitude and direction. Okay? What is this? This is a variable force. It is changing with X. So what we'll have to do is, we'll have to take the dot product of Fs and ds and then integrate that. Which means we are going to break the entire displacement into small displacements, calculate the work done due to those small displacements, and then finally add them up to get the final work done. Okay? And if we do that, and this is something you should remember, the work done by spring is equal to half k x1 square minus x2 square. Which means x1 is the initial elongation or compression, and x2 is the final elongation or compression. Okay? Is this clear? Okay, quickly give me a thumbs up if this is clear. OP player is saying, sir, I am studying class 8, but I like the session. Very good, OP. आप class 8 में ही इतना कुछ समझ जा रहे हैं, which is absolutely wonderful. So continue watching these sessions. Brilliant. Chalo, let's go to the next force. Okay. Now, as I said, if we have force which is variable in nature, it is not constant in magnitude and direction. In that case, we have to use F dot dr. Okay? If in that case you are going to use F dot s, you are going to make a big mistake. So whenever we have to calculate the work done, the first thing you have to understand is that is the force constant in magnitude and direction or not. Is that right? So this is going to become F dot dr, and the integration is going to go from the initial position to the final position. Okay? Now if this is a dot product, we can also represent it in terms of Cartesian coordinates. So we can write the force like this in the Cartesian coordinate system. We can write the small displacement dr in the Cartesian coordinate system, and when we take the dot product, it gives us fx dx plus fy dy plus fz dz. Then we can integrate this from xi to xf, yi to yf, and zi to zf correspondingly. Is that correct? Is this absolutely clear? Right? Chalo. ठीक है? So this is something we need to remember, that if we have a variable force, then we'll have to use integral of f dot dr. Okay. Now there is another meaning to work, and if we look at the graph of f versus x, if the displacement is happening only in one dimension, then we can plot a graph between f and x. Is that right? In that case, the work done is f dx integral. And we know what is f dx integral? The f dx integral between xi to xf is going to give us what? It is going to give us the area under the curve. Is that right? So that's another way of finding the work done. What is that? By finding the area under the curve. Is that correct? Is that clear? Sure. Perfect. A few definitions very quickly, and obviously you know all of these, but I'm just revising it quickly. Okay, there's nothing new, there's nothing that you don't know about this. Kinetic energy is equal to what? It is equal to half mv square. We know that, but important point to note here is that it is frame dependent quantity. Energy or work done, it is frame dependent quantity, because the velocity is dependent on the frame. Is that right? So the kinetic energy will also be dependent on the frame. Okay, clear? Now there is a relationship between kinetic energy and momentum. Okay, can we find that relationship? The momentum is mass times the velocity, and the kinetic energy is half mv square. So the relationship between kinetic energy and momentum is k is equal to p square by 2m, or p is equal to under root of 2mk. Okay, so if you know the momentum, you can find out the kinetic energy. If you know the kinetic energy, you can find the linear momentum. Is that clear? Perfect. Next, this is the most important part of this chapter, the work energy theorem. Okay, so the work energy theorem is a universal theorem. It is always true, always true in all situations. Okay, what does the work energy theorem say? Work energy theorem says that the work done by all the forces, okay, on an object, the work done by all the forces is equal to the change in kinetic energy. This is a theorem which you have to know. Okay, you must know this, otherwise it is going to be very difficult for you to understand this chapter. The most important theorem that you should know is the work energy theorem. Okay, Harshit is also here. Hello Harshit, good evening. यार Harshit टाइम पे आया करो, वरना थोड़ी चीजें आपकी मिस हो जाएंगी. Okay, चलो, is this clear? Is work energy theorem clear? ये बहुत इंपॉर्टेंट, ये सबसे फंडामेंटल थ्योरम है इस यूनिवर्स का, that the work done by all the forces is equal to the change in kinetic energy. Okay, BGM World is asking, how are we supposed to know, like when we should know when to apply work energy theorem? I will make you understand, BGM. When we solve problems, I will make you understand. Okay, don't worry about it. I'm going to show you how to apply. Okay, now there can be two kinds of forces. Okay, Ankit Anand is here. Hello Ankit. Again guys, टाइम पे आओ. क्लियर, बट अप्लाई करने में प्रॉब्लम होती है. अरे बाबा अंकित, सब अप्लाई करके दिखाएंगे, मत चिंता करो ना, सब अप्लाई करके दिखाएंगे. पहले फटाफट रिवीजन तो कर लें, वरना आप फॉर्मूला भूल जाओगे, आप कॉन्सेप्ट भूल जाओगे, तो फिर तो क्वेश्चन तो ऐसे ही नहीं बनने वाला है. तो फटाफट रिवीजन करते हैं, फॉर्मूला का, कॉन्सेप्ट्स का रिवीजन करते हैं, और उसके बाद क्वेश्चन सॉल्व करेंगे ना यार. बिल्कुल क्वेश्चन सॉल्व करेंगे, आपको अप्लाई करके मैं दिखाऊंगा. ठीक है, नेक्स्ट, कंजर्वेटिव एंड नॉन कंजर्वेटिव फोर्सेस. तो कंजर्वेटिव फोर्सेस क्या होते हैं? सर अप्रोचिंग करना बस बट 2 क्वेश्चंस में. अरे बाबा सिखाऊंगा, मैं सब सिखाऊंगा, डोंट वरी. आई विल शो यू हाउ टू अप्लाई दीज थ्योरम्स. मैं आपको सिखाऊंगा वर्क एनर्जी थ्योरम कैसे अप्लाई करना है, मैं आपको सिखाऊंगा एनर्जी कंजर्वेशन कैसे अप्लाई करना है, मैं सब सिखाऊंगा यार, चिंता मत करो. ठीक है, चलो. ओके, नेक्स्ट इज व्हाट इज कंजर्वेटिव फोर्स. इन अ राउंड ट्रिप, क्लोज पाथ का मतलब क्या है? जहां से स्टार्ट हुए वहीं पे वापस आ गए. सो इन अ राउंड ट्रिप द वर्क डन इज 0 ड्यू टू अ कंजर्वेटिव फोर्स. ओके, or we can say that the work done is independent of the path. Is that correct? दोनों एक ही बात है. Work done in a round trip is 0 or the work done is independent of path. So can you guys tell me a few names of a few conservative forces? Can you write the names of a few conservative forces? हाँ जी, initial final is same, but what I'm asking is, can you name a few conservative forces? Can you name them? Electrostatic force, very good Pratham. Tell me more. हर्षित, मेरे पास आकाश बायजूस की बुक्स हैं, पर उनसे कुछ सवाल पूछना है. आपको अगर कुछ सवाल पूछना है तो इट डिपेंड्स ऑन कोई कौन सा चैप्टर हम कर रहे हैं हर्षित. ठीक है, इट डिपेंड्स ऑन कौन सा चैप्टर कर रहे हैं, उस चैप्टर का अगर डाउट होगा तो मैं ले लूंगा. ठीक है, यस, ग्रेविटेशनल फोर्स इज अ कंजर्वेटिव फोर्स, स्प्रिंग फोर्स इज अ कंजर्वेटिव फोर्स. वेरी वेरी गुड. ठीक है, तो याद रखना है कि ग्रेविटेशनल फोर्स, स्प्रिंग फोर्स, इलेक्ट्रोस्टैटिक फोर्स, मैग्नेटिक फोर्स, दीज आर कंजर्वेटिव फोर्सेस. ठीक है। नमन इज आस्किंग सर कोलिजन्स पढ़ाओगे? भैया कोलिजन्स पढ़ाएंगे बट टाइम तो आने दो, ठीक है। रैंकर्स बैच आपने ज्वाइन किया है, आप जाके रैंकर्स बैच ज्वाइन करो, वहां पे अभी क्या चल रहा है, वहां पे अभी फ्रिक्शन चल रहा है, उस रैंकर्स बैच में हम कोलिजन भी पढ़ाएंगे, ठीक है। हाउ इज मैग्नेटिक फोर्स कंजर्वेटिव, ठीक है। तो हम लोग प्रथम रिमेंबर दैट हम लोग वी डिफाइन पोटेंशियल एनर्जी, and when we define potential energy we can only define it for a conservative force. तो जब हम मैग्नेटिज्म पढ़ेंगे तो आई विल शो यू, ठीक है। सो देयर इज मैग्नेटिक पोटेंशियल एनर्जी, ठीक है। डाइपोल्स होते हैं ना, डाइपोल्स की पोटेंशियल एनर्जी होती है, दैट कैन ओनली बी डिफाइंड, पोटेंशियल एनर्जी कैन ओनली बी डिफाइंड फॉर कंजर्वेटिव फोर्सेस, ठीक है। सोमेश इज सेइंग सैटेलाइट रिवॉल्व्स अराउंड प्लैनेट, सो इज देयर वर्क डन? Zero. Satellites revolve around the planet, so is their work done? Zero. Yes, Somesh. Yes, you are absolutely right. Work done by what? Work done by the gravitational force. Yes, that is always going to be zero. Yes, you are absolutely right. ठीक है। Is centripetal force conservative? अरे बाबा, centripetal force is a force which is providing a force towards the center. Now centripetal force is not a new kind of force. Centripetal force is a force and any force can act as a centripetal force, ठीक है। Centripetal force, gravitation force can act as a centripetal force, electrostatic force can act as a centripetal force, tension can act as a centripetal force, normal can act as a centripetal force, spring force can act as a centripetal force. सो सेंट्रीपिटल फोर्स इज नॉट अ न्यू काइंड ऑफ फोर्स जिसको हम कंजर्वेटिव नॉन कंजर्वेटिव बोल सकते हैं। एनी फोर्स कैन एक्ट एज अ सेंट्रीपिटल फोर्स, इज दैट राइट? समझ में आया प्रथम? ओके। कैन यू गिव अ ट्रिक वेयर इज एग्जैक्ट वर्क डन? जीरो। कैन यू गिव अ ट्रिक वेयर इज एग्जैक्ट वर्क डन? जीरो, ठीक है। देखो ना, वे बहुत सिंपल है। सो यू टेक एन ऑब्जेक्ट एंड द ऑब्जेक्ट इज ड्रॉप्ड, ठीक है। ऑब्जेक्ट रीचेस द ग्राउंड, like this is height h, and then again the object is taken up, ठीक है। first it is taken down and then it is taken up, okay। now is this a round trip? Yes, this is a round trip, okay, because first it has gone down and then gone up, so the initial and final positions are the same, so this is a round trip. Now when it is going down, the work done by the gravitational force is how much? It is mgh. But when it is going up, the work done by the gravitational force is how much? It is minus mgh. So what is the total work done in a round trip? The total work done is zero. Is that correct? Clear? Pratham is saying for a conservative field, can we say closed integral of f dot dr is equal to 0? Yes, absolutely. Yes, Pratham, you are absolutely right. Closed integral of f dot dr, where f is a conservative force, is always going to be 0. All right, clear? Any problem so far? If everything is clear, quickly give me a thumbs up. Okay, next. Work done by non-conservative force depends on the path taken. What are non-conservative force? Friction, tension, normal. These are non-conservative forces, and work done by them will depend on the path. Somesh is asking, so in cases where displacement becomes 0, always work done is 0, right? No, Somesh. Only for conservative forces. Now in this case, what is this? This is non-conservative force, ठीक है। मान लो we have friction, okay? What do we have? We have friction. So let's say this block is displaced by a distance d, and then this block is brought back, okay? What is the force here? The force here is friction, and friction is a non-conservative force. So when it is going towards the right, the friction is going to be in the opposite direction, the displacement in the right hand side. So the work done is going to be how much? It is going to be minus Fd. But when the block is going towards the left, the friction is then going to act towards the right. The friction is still going to be opposite to the displacement. So in the reverse trip also, the work done is going to be minus Fd. So the net work done becomes minus 2 Fd. Is that correct? So the work done in a round trip will not be 0 for non-conservative force. Shetty is asking, does viscous force is a non-conservative force? Yes, Shetty. Frictional force, viscous force, these are non-conservative or dissipative forces. Okay. Naman is asking, sir, does that mean if we see from different perspective, work done can be changed? Yes, Naman, work done is frame dependent. Absolutely. Work done is frame dependent. BGM World is asking, can we expect one question from this chapter for mains? Definitely. Okay. Definitely one question you can expect from this chapter. But what I said initially in this video is that this is not just about one question. You cannot study any chapter after this without work energy theorem or without conservation of mechanical energy, without work power and energy. You cannot study any chapter. When you are going to study collision, you are going to have to work with, you will have to know work power energy. In rotation, you will have work power energy. In gravitation, you will have work power energy. In SHM, you will have work power energy. In waves, you will have work power energy. In fluids, you will have work power energy. In electrostats, you will have work power energy. In magnetism, you will have work power energy. You just cannot escape work power energy. Okay? So it's not just about one question. It's about the concept. It is going to be applied in every chapter. Okay? Chalo. Let's move forward. नेक्स्ट किसकी बात करते हैं? पोटेंशियल एनर्जी की बात करते हैं. ओके, नाउ व्हाट इज पोटेंशियल एनर्जी? पोटेंशियल एनर्जी is basically potential energy. We cannot define potential energy. What we can define is a change in potential energy. So the change in potential energy is defined as, or I can write it like this. The change in potential energy is defined as negative of work done by the internal conservative force. Okay, it is the negative of work done by the internal conservative force. So in this case, what do we have? We are talking about the gravitational potential energy. So what is our system? The system is the mass and the earth. What is the system? The mass and the earth, and this is the gravitational potential energy. So the negative of work done by the gravitational force will be equal to what? It will be equal to the change in potential energy. Okay? So the change in potential energy in this case becomes what? It becomes mgh. But what we take, okay, when height is 0, we consider it to be, we assume it to be potential energy 0. We assume it to be a reference for, or we call it datum as well. Okay? So if it is raised by a height h, the potential energy increases by mgh, and if it falls by a height h, the potential energy decreases by mgh. Pratham is asking, sir, is there something called magnetic potential energy? Yes, there is something called scalar magnetic potential energy. Okay, there is something called that. Okay, so for example, if you take a bar magnet and you put it in a magnetic field and you rotate it, okay, in that case what will happen? It will have some scalar potential energy. अब इसके बारे में डिटेल में बात करेंगे जब हम मैग्नेटिज्म पढ़ेंगे. ठीक है, इट इज, इसकी पोटेंशियल एनर्जी कितनी होती है? माइनस म्यू डॉट बी. ठीक है, पढ़ेंगे, उसके बारे में पढ़ेंगे जब हम मैग्नेटिज्म पढ़ेंगे. ऑलराइट, चलो. अब वैसे ही क्या होता है? स्प्रिंग पोटेंशियल एनर्जी होती है. Again, what will be spring potential energy? Just change in potential energy would be the negative of work done by the internal conservative force. And what is the internal conservative force? Spring force. Okay. So potential energy becomes half kx square. ये पता है? Potential energy of the spring becomes half kx square when we assume zero elongation or compression. That is the natural length to be the zero potential energy datum. Is that correct? ठीक है, तो स्प्रिंग मास सिस्टम की पोटेंशियल एनर्जी कितनी हो जाएगी? हाफ के एक्स स्क्वायर, वेयर एक्स कैन बी द इलोंगेशन और कंप्रेशन. ओके, नाउ वेरी क्विकली लेट्स टॉक अबाउट इक्विलिब्रियम. ओके, व्हाट काइंड ऑफ इक्विलिब्रियम इज दिस? इफ यू पुट एन ऑब्जेक्ट ओवर हियर, इफ यू डिस्प्लेस इट, what will happen? It will slide down. This is unstable equilibrium. For unstable equilibrium, the potential energy has to be maximum, which means du by dx should be equal to 0 and the double differential should be equal to negative. Okay? For equilibrium, for stable equilibrium, the potential energy should be minimum and du by dx should be equal to 0 and d square u upon dx square should be positive. Okay? And for neutral equilibrium, du by dx is equal to 0, which means u should be constant. Okay? So yes, I will give you the PDF So you join the Telegram channel, link would be in the description. You will receive the PDF of this lecture. Okay? Okay. Now this is another very important part. What is this? This is conservation of mechanical energy. Okay, now understand this. When we say work done by all the forces, we can say that the work done by external force plus the work done by non-conservative force, okay, this will be equal to the change in kinetic energy plus the change in potential energy. This is one way of writing work energy theorem. Okay? This is one way of writing work energy theorem. Okay? So you classify all the forces as external or non-conservative. So the work done by external force plus work done by non-conservative force will be equal to delta K plus delta U, the change in kinetic energy plus the change in potential energy. This is the work energy theorem. Okay? Correct? Okay. Now, in case there is no work done by the external force and there is no work done by the non-conservative force, in that case, what will happen? In that case, delta K plus delta U will be equal to 0. What does it mean? It means that the total mechanical energy, the change in the total mechanical energy is equal to what? It is equal to 0, which means that the mechanical energy of the system will be conserved. Okay, understand this very carefully. If there are external forces, is it necessary that the energy conservation will not take place? No. Only if the work done by the external force and the work done by the non-conservative force is 0, we can say that the mechanical energy of the system will be conserved. Okay? And whether to use work energy theorem or whether to use conservation of mechanical energy will depend on the choice of the system, and I'm going to show that to you. Alright, chalo, this is clear, work energy theorem. And quickly let's define average and instantaneous power. What is average power? Average power is work done divided by time, and instantaneous power is F dot V. It is dW by dt and it becomes F dot V. That is the instantaneous power. This is instantaneous, F dot V. Okay, is this clear? This is the theory I have covered. It's a long chapter, but this is rapid revision, so I have covered the theory in less than 30 minutes. If the theory so far is clear and it has helped you revise, then quickly give me a thumbs up, quickly like this video, and quickly subscribe to the channel, because so that you don't miss any updates. Okay. Pratham is asking, sir, in case of stable equilibrium, when the object is displaced from potential, well, the object oscillates about the point of stable equilibrium. Yes, Pratham, it can oscillate. SHM में जैसा होता है, बिल्कुल जैसा SHM में होता है, it can oscillate. प्रज्वल is saying, theory समझ में आ गया पर questions नहीं बनते सर. बनेंगे बाबा, questions बनेंगे. आपने बोला और question आ गया. अब हम question solve करेंगे, ठीक है? Mechanical energy is the sum of potential energy and kinetic energy. उसको mechanical energy बोलते हैं, ठीक है? The sum of potential energy and mechanical energy. चलो, let's start. Ready? Let's start this question. So what do we have? We have a ring of mass m and it is connected, it can slide over a rod. Okay? The spring constant is K and this rod is at a height h. Initially the spring is making an angle of 37 degree and the natural length of the spring is h. ठीक है? Spring का natural length कितना है? Spring का natural length है h. Now the question is, if the ring is released from here, when it reaches this point, what will be the velocity? Okay, this is the question. Is the question clear? Guys, is the question clear? Quickly give me a thumbs up if the question is clear. Any problem with the question? ठीक है? Question is very straightforward. Clear है? चलो. Now first what we are going to do is, we are going to use work energy theorem to solve this question. ठीक है? What are we going to do? We are going to use work energy theorem to solve this question. ठीक है? Now work energy theorem क्या बोलता है? Work done by all the forces is equal to change in kinetic energy. So what do we have to see? What are the forces that are acting on this particle? Okay, what are the forces that are acting? Okay, there is mg, right? There is gravitational force. There is spring force. Okay, there is spring force. What other force? There will be normal force from this rod. Okay, and there is no friction, so we can ignore friction. Only spring force and gravity do work. Wait Pratham, wait. देखते हैं. Let's see. Okay, is this clear? So how many forces are there? There are 3 forces. What are those forces? The normal force, the spring force, and the gravitational force. So work done by all these 3 forces will be equal to what? It will be equal to the change in kinetic energy. Is that correct? ठीक है. अब let's start with the work done by normal force. The normal force is always going to act perpendicular to the rod, and the ring is going to slide along the rod. So what will be the work done due to the normal force? The work done due to the normal force will be equal to what? It will be equal to 0. Is that correct? Do you agree? Is that correct? Give me a yes if this is clear. The normal force is always going to act perpendicular to the rod, and it is going to slide along the rod, which means that the normal force is not going to do any work. Correct? ठीक है. पवन, अरे बाबा नॉर्मल फोर्स कैसा लगता है? नॉर्मल फोर्स हमेशा सरफेस के परपेंडिकुलर लगता है ना. So the normal force is going to act perpendicular to the rod, and this ring is going to slide along the rod. So the displacement and force are perpendicular to each other, which means the work done is going to be 0. Similarly, think about it. What is gravitational force? mg is downwards, but the displacement is horizontal. So work done by the gravitational force is also going to be 0. Do you agree? The work done by gravitational force here is also going to be 0, because you can see there is no change in height. Correct? Now only thing remaining is what is the work done by the spring force. The work done by the spring force is half k x1 square minus x2 square. Do you agree? So the first thing we want to find out is what is x1. What is the elongation of the spring? Correct? So let's find that out. So from this triangle, now this is h, this is 37 degree. So this is going to be h divided by cos 37 degree. Okay, what is the length? What is the new length? The new length is h divided by cos 37 degree. What is cos 37 degree? Cos 37 degree is 4 by 5. Okay. So this is the length of the spring right now. This is the length of the spring right now. What is the original length of the spring? The original length of the spring is h. The natural length of the spring is h. So h by 4 is the elongation. Is that correct? So h by 4 is the elongation of the spring in the initial position. Is that correct? Okay. In the final position, when the ring is over here, what is the elongation? The elongation is going to become 0, because it is going to be in that at its natural length. ठीक है? तो ये कितना हो जाएगा? ये हो जाएगा half k h by 4 square minus 0 square. Correct? Is this the work done? This is the work done. So ये कितना हो जाएगा? ये हो जाएगा k h square divided by 2 into 16. Is that correct? So this will be the work done by the spring force. This will be equal to what? This will be equal to the change in kinetic energy. BGM is asking why x2 is 0. Baba, जब यहाँ पे पहुँच गया ring, when the ring has reached over here, what is the length of the spring? The spring length is, the natural length of the spring is h. So the elongation in the spring is going to be what? The elongation in the spring is going to be 0, because now the spring is going to be at its natural length. Is that correct? Okay. Clear? x2 0 क्यों है? Clear BGM? Okay. So this will be, what is change in kinetic energy? The final kinetic energy minus the initial kinetic energy. Okay. If the speed here is v, half mv square will be the final kinetic energy, minus what is the initial kinetic energy? Initially it was at rest. So this becomes half mv square minus 0. Pawan is asking how x1 is equal to h by 4. Baba, Pawan, ये लेंथ कितना है? ये लेंथ कितना है? ये h by cos 37 डिग्री होगा. 5h by 4. h divided by 4 by 5. कितना हो जाएगा ये? 5h by 4. ठीक है. ये क्या है? ये है लेंथ ऑफ द स्प्रिंग अभी. लेंथ ऑफ द स्प्रिंग अभी. बट अपने को क्या चाहिए? अपने को इलोंगेशन चाहिए ना. तो ओरिजिनल जो लेंथ है स्प्रिंग का, उसको सब्ट्रैक्ट करना पड़ेगा. सो 5h by 4 minus h is going to give us what? It is going to give us h by 4. आई बात समझ में? क्लियर? Okay, Naman Narula is saying, sir, can initial kinetic energy be founded by law of conservation of energy? हाँ, initial kinetic energy नहीं, final kinetic energy. That's what you mean. Initial kinetic energy तो zero है. So that can be found using conservation of mechanical energy, and we are going to do that over here. Don't worry. ठीक है? Okay, so is this clear? Is this absolutely clear? Any problem? ठीक है? Clear है? So from here, what will be? This 2 and this 2 is gone. So V will be 1 by 4 K by M under root and then H. So H by 4 under root K by M. ठीक है? So work energy theorem, application of work energy theorem. Is this clear to everyone? Quickly give me a thumbs up if the application of work energy theorem is clear to everyone. Quickly give me a thumbs up. Very good. ठीक है? अब देखो, अब सेम प्रॉब्लम व्हाट वी आर गोइंग टू डू इज वी आर गोइंग टू सॉल्व इट यूजिंग व्हाट? वी आर गोइंग टू सॉल्व इट यूजिंग एनर्जी कंजर्वेशन. ठीक है? सो इस केस में आई विल चूज अ सिस्टम. ओके, नाउ अंडरस्टैंड व्हाट इज माय सिस्टम. माय सिस्टम इज द मास. द चॉइस इज सिस्टम इज कंप्लीटली डिपेंडेंट ऑन यू. सो मास, ठीक है, जो रिंग है, so ring plus the spring plus the earth. ठीक है? क्या किया मैंने? ring plus spring plus earth. This is my system. ओके, तो इसको मैं इरेज कर रहा हूं. ठीक है? व्हाट इज माय सिस्टम? ring plus spring plus earth. This is my system. Now any force which is acting between these things is going to be an internal force, and anything which is going to act from outside of these three things is going to be an external force. ठीक है? Okay. अब what are the forces here? There is mg, there is the spring force, and there is the normal force. Now tell me, out of these, which are the internal forces? Quickly tell me, out of these, which are the internal forces? Can you explain that? Or can you answer that? चलो फटाफट मेरे को बताओ. Out of these three forces, which are the internal forces? ध्यान में रखना, what is my system? My system is ring, spring, and earth. Yes, mg. mg is the force between the ring and the earth. So this is an internal force. उसके बाद spring force. Spring force is the force between the ring and the spring. So what is this? This is an internal force. Is that correct? Okay. What is normal force? So the only external force is the normal force, because this rod is not part of the system. कर समझ में आ रहा है? Rod is not part of the system. So rod is going to be an external object. So the force exerted by the rod on the ring is the normal force. So this normal force is going to be what? This normal force is going to be the external force. Agreed? Agreed? Okay. Now what is the work done by the external force? Is there any friction? No, there is no friction. So work done by friction is zero. Is there any so what is the work done by the external force? What is the work done by the normal force? The work done by the normal force is what? The work done by the normal force is zero. अरे बाबा सोमेश, मेरे सिस्टम में क्या है? मेरे सिस्टम में रिंग है, स्प्रिंग है और अर्थ है. रॉड है क्या मेरे सिस्टम में? So the choice of system is mine. So I have chosen the ring, the spring and the earth as the system. तो रॉड क्या है? रॉड तो बाहर की चीज है ना. So if an external object is applying a force, then it will be an external force. Correct? ठीक है? Now the work done by the external force is zero, and the work done by the non-conservative force is also zero. This is the condition for applying conservation of mechanical energy. Yes or no? This is the condition to apply conservation of mechanical energy. Now the work done by the external force is zero. There is no non-conservative force. So the work done by the non-conservative force is zero. This gives me the license to use conservation of mechanical energy. So how do I conserve mechanical energy? Ui plus Ki. This is the initial mechanical energy. This has to be equal to Uf plus Kf. This is the final mechanical energy. ठीक है? Let's start. ठीक है? What is Ui? Elongation of the spring we have already calculated. It is h by 4. वो दोबारा calculation नहीं करेंगे. ठीक है? We have already calculated that. Okay. Now initial potential energy. The ring is over here. What are the potential energies involved? There is gravitational potential energy involved, and there is spring potential energy involved. Correct? Do you agree? Now the force between the spring and the ring is the spring force. So it is an internal force. It is a conservative force. So what energy is involved here? The spring potential energy is involved here. Now the ring and the earth is also in the system. What is the internal force? Gravitational force is the internal force. Is it a conservative force? Yes. So what potential energy is involved here? The gravitational potential energy is involved here. Correct? So I'm going to write the initial potential energy. ठीक है? So first I'm going to write the initial potential energy for the spring. तो वो कितना हो जाएगा? Half k into x square. Correct? When the ring is over here, the elongation of the spring is h by 4. So the initial potential energy of the spring will become half k h by 4 square. Correct? Now in order to find the gravitational potential energy, you have to choose a reference. ठीक है? So I am choosing this reference. ये जो rod है ना, इसी की height को मैं reference choose कर ले रहा हूं. ठीक है? Which means that the gravitational potential energy will become zero because of this reference. ठीक है? So what is the initial gravitational potential energy? Zero. ठीक है? Because I have chosen that reference. Correct? Plus, what is the initial kinetic energy? When the ring is over here, the kinetic energy is zero. So this is the initial kinetic energy. This is equal to, what is the final spring potential energy? When the ring is over here, the spring is back to its natural length. So what is x? X is 0. So initial potential energy of the spring will be, final potential energy of the spring will be what? It will be 0. When the ring is over here, has its height changed? Its height has not changed. ठीक है? Its height is still 0. With reference to my reference, the height is still 0. So gravitational potential energy is also 0. What is the final kinetic energy? When it reaches here, let's say its speed is v, so the final kinetic energy is going to be half mv square. यहां से भी क्या आंसर आएगा? यहां से आंसर आएगा आपका h by 4 under root of k by m. आ गया आंसर. सार्थक, मैं हमेशा आपके लाइव क्लासेस मिस कर देता हूं. सार्थक, यू ज्वाइन माय टेलीग्राम चैनल. ठीक है? यू ज्वाइन माय टेलीग्राम चैनल. वहां पे यू विल गेट द अपडेट्स. ठीक है? लिंक डिस्क्रिप्शन में होगा. यू ज्वाइन माय टेलीग्राम चैनल, यू विल गेट द पीडीएफ नोट्स एंड यू विल गेट द शेड्यूल देयर ऑल्सो. यू विल गेट नोटिफिकेशंस देयर ऑल्सो. तो आपका क्लास मिस नहीं होगा. बीजीएम वर्ल्ड इज आस्किंग, work energy theorem, energy conservation, momentum conservation. I'm confused, sir. Can you just point out the instance when to apply what like that through example or something? ठीक है? So BGM world, momentum conservation is a different thing. ठीक है? Momentum conservation is a different thing. Momentum conservation में क्या होता है? If the work done by, if there is no external force on the system, the momentum is conserved. उसकी बात हम बाद में करेंगे. But if you have to choose between work energy theorem and energy conservation, उस केस में क्या करोगे? You can use either. It is equivalent. समझ में आ रहा है? BGM. You can choose work energy theorem or you can choose conservation of mechanical energy depending on the system you have chosen. ठीक है? The same problem I have solved with work energy theorem also. The same problem I have solved with energy conservation also. ठीक है? But solving with energy conservation becomes a little simpler. ठीक है? तो whenever, so if I have to give you one point over here, one tip over here, I'll tell you that if the work done by the external force and the work done by the non-conservative force is 0, go for mechanical energy conservation. But if there is work done by external force or if there is work done by friction, then go for work energy theorem. Okay? This is my tip to you. Naman is saying, sir, can we devise system according to our will? Absolutely. Absolutely. आप अपने हिसाब से सिस्टम चूज करो एंड उसके हिसाब से देखो कि एक्सटर्नल फोर्स वर्क डन कर रहा है कि नहीं कर रहा है, उसमें इंटरनल फोर्सेस कौन से हैं, तो उसमें आप वर्क एनर्जी थ्योरम लगाना चाहते हो या आप उसमें एनर्जी कंजर्वेशन लगाना चाहते हो. इट एब्सोल्युटली डिपेंड्स ऑन यू. Pratham is asking, sir, my rotation chapter is strong except for angular momentum conservation. I'm not able to write the equation for angular momentum conservation even though I know when to use conservation of angular momentum. Pratham, हम लोग जब rotation की बात करेंगे ना, उसमें we will talk about angular momentum. ठीक है? Don't worry about that. Alright? ठीक है? उसमें हम लोग बात करेंगे. ठीक है? Is this clear? Somesh is asking, sir, if we can choose system, can we include rod in the system also? Yes. आपकी मर्जी, rod को भी system में ले लो, rod को भी system में ले लो और करके देखो. Play with this question, ठीक है ना? Play with this question and see कि किसको system में लेंगे तो क्या होगा. Ultimately answer सबसे same आएगा. ठीक है? So all you have to do is after choosing the system, be careful which is going to be the external force. Be careful which is going to be the internal force. Okay, that's all you have to worry about. Okay, so I have taught you how to apply work energy theorem as well as the conservation of mechanical energy. Okay, so I'm going to end this session right now. Okay, this was a power packed session. Do tell me in the comments how did you find this session. Do tell me that what more can we do in these sessions, or what was the thing you liked, what was the thing you did not like. Do give us a feedback and then we will try to work according to that. Okay, but if you like the session and if you think that this session was helpful for you, then please give me a thumbs up. Please like this video, please subscribe to the channel, and you can also subscribe to my Telegram channel. The link is in the description. There you're going to get notes, there you're going to get a lot of extra stuff as well. Okay, we want more questions. Correct, Pawan, you are right. Questions हम लोग करेंगे और questions करेंगे. So the next time I'm bringing a session, next time I'm bringing rapid revision, I'll make the theory even more concise and I'm going to focus more on questions. ठीक है? I also felt कि आज हम एक ही question कर पाए because of the time constraint. I understand that. ठीक है? But बहुत ही important question किया where we cleared our concept. But you are right, we are going to do more questions. So in the next sessions, we are going to do more questions. We'll have 25% theory and 75% questions. Is that right? ठीक है? Is that fine? 25% theory and 75% questions. ये चलेगा? ठीक है? ये चलेगा तो give me a thumbs up. Okay? Extend session, do one more question. Sir, नहीं कर सकते because there is another session that is going to happen right now. ठीक है? But these are going to be very frequent sessions. तुम चिंता मत करो. ठीक है? We are going to have many sessions like this. ठीक है? So don't worry. Just keep following us. You'll have many sessions. We are going to solve many questions. ठीक है? Correct. 1 घंटा कैसे बीत गया पता भी नहीं चला. PDF notes आपको मिल जाएगा मेरे Telegram चैनल पे बाबा. Go to my Telegram channel. उसको अपने Telegram चैनल मेरे टेलीग्राम चैनल को आप ऐड कर लो, आपको पीडीएफ नोट्स वहां मिल जाएगा. ठीक है, चलो, थैंक्स अ लॉट गाइस, यू गाइस वर ऑसम, यू गाइस वर सुपर फन, वी हैड अ सुपर इंटेंस इंटरैक्टिव सेशन. आई होप यू लाइक्ड इट. ठीक है, तो we'll meet very soon again in the next session. Till then, keep practicing, keep getting better, and remember, you guys are rankers. Thank you so much.